Hello. GM, everyone. Hey, man, good. Nice to see you again. Hey, so yeah, my name is Tony Olendo, and I'm happy to be here to talk about how we could issue verifiable credentials using Polygon ID on Lens. And I guess this is just where we kind of begin. So my name is Tony again. I'm a DevRel engineer at Polygon, and I'm Tony Olendo on Twitter, on Telegram. Unfortunately, all my DMs are open, so please, if you want to message me, please do. But just understand the rate of reply might not be as efficient as it usually is this week, and even after that. So let's begin. So what is Polygon ID, right? I'll rush through some of the base stuff, and then we could get into like the specific application and use case later. But for the sake of people who've never heard of Polygon ID, I'll be doing like a brief, just a general understanding so that you could get a feel of what it looks like from the beginning, right? So Polygon ID, with the help of zero-knowledge proofs, lets users prove their identity or make any other kind of attestation without exposing their private information. And what that does is that it ensures freedom of expression and privacy by default, right? So for instance, let's say that I am attesting that I hold a job at Polygon Labs. So you'll see over here, I'm saying that I hold a job at Polygon Labs. It might be true, it might not be true, but let's say we have an issuer that is verifiably saying, yeah, this is actually true, Tony works at Polygon Labs. And I'll say previously, I used to work at Coordinape, shout out Coordinape. Anybody knows Coordinape? A DAO management tool, really cool. No? Okay. So I guess there are no DAO people in the crowd. But yeah, Coordinape was a really cool, is a really cool DAO management tool, and I had the pleasure of working there for a couple of months. But these are two primary attestations I'm making about myself, right? And those attestations, as far as data, could be boiled down to a string, which says who I was employed by, whether or not I had a technical role, and my start date, right? So those are just three pieces of information that might be of use to a potential employer who wants to know if they could hire me, right? I could also issue a verifiable credential about anything else I like. Oh, by the way, shout out to Steph. Most of these slides are based on some stuff that she would have presented before. I'm just customizing to get past the initial base understanding. But this dog is actually mine, okay? But basically, I could attest, you could basically attest to anything online and say, yeah, I actually do own a pet. The data types could be anything from, does he have a dog or does he have a cat, and the number of pets that they have, right? But how do we know that these claims are true, right? So if you really think about it, what we're actually wrapping here are things known as verifiable credentials. So these are essentially attestations or claims that are tamper evident, and they're basically cryptographically verifiable, right? And what that enables us to do is that it basically elevates the trust assumptions that we're making online beyond just LinkedIn saying, verifying your email or something of that sort. We could actually issue verifiable credentials against your actual employment history. And the use of verifiable credentials is something that we know, well, we hope will continue to proliferate. But it's basically a claim, which is an assertion about a particular subject. So the subject could be dog ownership, employment history, the college that you graduated from. Anything and everything about you as an individual could be attested to online, and anything about any other entity could actually be attested to online. And a cryptographic proof could be generated that other consumers of that cryptographic proof could essentially rely on, because it has been verified, right? Yeah, so for instance here, I could come and say, yeah, I worked at Polygon Labs and I worked at Coordinape, and once they're verified against something known as a schema, and more on that later, but essentially we could actually begin to rely on that. But if, say, Zuri, my dog, says she's employed by NASA, and so now we have to kind of like figure out how we're going to verify all of that information. So with that, it basically introduces the concept of the triangle of trust, which is comprised of three primary actors. So there's an issuer. The issuer could be Polygon Labs. The issuer could be anybody else. It could be my vet who knows my dog history. And there is the identity holder, which is me and you. So you and I could hold identities, could hold claims inside of our wallet, and the zero-knowledge proof is then sent to a verifier. Let's say somebody who's selling pet food or is looking to employ me or something of that sort. They could actually use the verification and actually have confidence in the claims I'm making and in the assertions that have been made about me. So if you look at it in practice, my former manager called Liam at Coordinate could issue a claim that verifies that, yeah, this guy actually worked here. And further, they could actually attest whether or not I had held a technical role. And anybody else who's like verifying that could actually come and now say, okay, yeah, we actually have confidence, right, that this person works everywhere. So I'm hoping the example is kind of clear, but if not, famous issuer is the Sorting Hat at, wow, I forget the name of the school. Hogwarts, my word. Yeah, so at House Gryffindor, there was a sorting hat that essentially was like an issuer, and it issued credentials about various people, and it said you belong to this house or that house and various houses, and it becomes like a very interesting tool that we could use to kind of imagine what that looks like. But when you actually got your verifiable credentials, you could open a the verifiers could be the magic door or a team captain. So essentially a team captain, you would actually go to the team captain and say, I am of House Gryffindor, and because of that, you could then unlock something else, which is probably joining the Quidditch team, or you could open the magic door and you could enter the Gryffindor common room. So those are some of the like practical use cases you could imagine for Polygon ID specifically. Beyond that, we have the Polygon ID wallet app that holds your verifiable credentials. And this is vastly different from when, if you imagine what your identity currently looks like, if you're using Google or something of that sort, where you have no access to the Google database. You're not carrying it around. You don't know who's accessing. You don't have any control or agency over your own identity. But other people are relying on your Google identity to be able to give you access to the Gryffindor common room or something of that sort, right? So with this, we kind of flip the script on that, and we essentially make it such that you have primary control of your verifiable credentials. And basically, it's a digital wallet that holds your verifiable credentials and interacts with an issuer to fetch and store VCs. And it also acts as a verifier to share ZK proofs. And this is what it looks like essentially when a credential is issued. You would see the first screen there where there's an offer that's being made. You add a claim. From there, it's being held inside of that. And you could actually see like your various, on the My Data page, you could see the various verifiable credentials that you hold. And if you tap on them, it shows a lot more information about that. And from there, you could also go through the whole process of like verification, and you could generate proofs based on your claims, right? And there's a whole querying system that essentially says, if you were over 21, you could actually generate a proof that simply states that you're over 21, and without necessarily releasing your underlying date of birth. And that essentially brings us to like the end of the intro. So if you've never heard of Polygon ID before, I hope that makes sense. Is there anybody in the room who didn't understand Polygon ID before? I hope that was helpful. But for now, let's talk about Lens, right? And Lens is basically a Web3 social graph on the Polygon proof-of-stake blockchain. It's designed to empower creators to own the links between themselves and their community. But specifically, if you're looking at like how do we then effectively provide a layer of privacy on top of the Lens social graph, then we have to consider solutions such as Polygon ID that do not necessarily take away the empowerment that we are attempting to give our creators on Lens. And for that, I do not trust the internet at conferences, so I recorded a demo of the application that I built, which is like a, yeah. I mean, famous last words. I've seen, I've seen things go awry several times. So I'm going to show you just a brief demo that is designed to just help crystallize a couple of concepts, and then from there I'll just take you through how it was built, like behind the scenes. So this is a demo sample I built. Basically has an integration to Lens, so we connect to Lens there, and you could once you actually sign the transaction, it then verifies and says, okay, you have a Lens profile, those are the number of followers you have, and those are people following you. Then from there, we create a Polygon ID profile, and by that, we are creating the issue on the back end, and we are generating a verifiable credentials. From there, we are getting like a QR code that essentially a user with a Polygon ID wallet could scan. And from there, they could actually hold that verifiable credential on their wallet, right? There's a lot about Polygon ID and the whole system that I am condensing, just in the interest of time. But let's go through what that looks like here. If you want to see the repo for this, it's up there where you could actually get access to it and see how the demo works on the back end. So I'll give you maybe a minute or two or something. Okay. We should have had this at the demo where Miros would have been playing some piano on the side where people like lift up their phones to get the QR code. Next time. Cool. All right, so this is it's a basic React application. It just has two primary API calls. So there's things I'm going to abstract away to show you just what it looks like. But this is what the process essentially looks like, at least for me. One, we're starting off with setting up the issuer node, which is like the core protocol that we're using in Polygon ID for people to generate verifiable credentials and decentralized IDs and so on and so forth. And then from there, we create an issuer, right? So the issuer essentially is like an authority that you could think of that basically issues attestations about various people. If you're building any type of application on Lens, for instance, be it like you want to extend via KYC, you want to issue different kinds of social proofs, your particular entity could essentially become an issuer. And once you create an issuer, you need to design and implement your schema. And I'll show you how we kind of do that at a high level, where you could design a schema that you could make available for use and consumption on your applications. Then from there, you would query the Lens API and finally issue a verifiable credential. And just for your benefit, there are a couple of things you'll do once, a couple of things you'll do several times, right? So you'll only set up an issuer node once. You'll only create an issuer that I hope you're going to store in a database somewhere, because once you create an issuer, it issues a decentralized ID, and that decentralized ID is then used to issue subsequent claims against your particular issuer. And then from there, you only need to design a schema once for the particular application that you're actually building and for the verifiable credential that you want to design. And once you have that, that's like the base. Then what you'll be doing when users subsequently come to your application and they connect the Lens profile, they would essentially simply be querying the API, and once they query the API, they issue a verifiable credential, and that's something that your application could continue to do moving forward. So first step is issuing is the issuer node. It's a fairly involved process, but there's a lot more people that we're bringing on board: platform providers, software as a service providers. I think Doc is in the room. We have Gatekeeper. We have a couple of other partners that we're working with. But if you like to dev on hard mode like me, the issuer node is available for you to set up on your own. And we have the docs and the code for it. And there's an entire video that we recorded here. I'm not sure why the image isn't showing. But again, you see, but you guys understand why I don't trust the internet at conferences, right? So you actually have this is a whole very comprehensive talk that Steph gave on like the issuer node 101. So it takes you through all of like the full gamut. It's about an hour long, but it's sectioned out really, really well. So if you want to understand different bits and portions, you can. If you want to abbreviate that whole process and just jump ahead to the Docker setup, if you're playing with this locally, you could actually quickly do that. And once you get that up and running, we could then move on to the process. So again, just to recap, the first step is you set up the issuer node, and you basically ensure that you could now issue verifiable credentials. And then from there, we want to create an issuer, right? So once you have everything set up, and it goes through the process where you have like a username and a password that's available for you to make API requests. You basically just make a single API request to create an issuer. And as you could see on the, this would be your left. We have the request where we are essentially specifying the blockchain and the network that we want you to actually, well, you would like VCs to be issued against, and that could be Mumbai, I think, for now, and Polygon POS, but we're adding support, and you could basically change this to whichever blockchain that you prefer. And from there, once you actually make that request, you would then get a decentralized ID on I guess your right, which has the identifier, and the identifier is essentially what you hold, and that's what you store if you're building your own application. So if you lose that, you then have to create a new one, and you lose all of the claims and all these things. So you want to ensure that that is stored fairly safely. But once you then create an issuer, you could move on to the next step, which is creating a schema. And a schema essentially encodes the structure of a particular verifiable credential. So it's essentially the structure of how you want, basically the shape of your data. And you could actually create it against like integers, strings, date values, and booleans, and various data types that we support. And there's a lot more information on the website about how to actually do this. But the beauty of verifiable credentials is that they're an open standard, and you could actually they are designed to be interoperable, which is why it's easy for Polygon ID to work with partners such as Doc and so on and so forth, because we have we have a standard that we all support all together. And the schema is essentially comprised of two primary pieces, which is the JSON linked data context, which contains just a description of the type and again the fields, and then the actual schema, which has the validation rules that you're actually considering for the issuer node. So the schema that you define essentially tells the issuer node what the state of play is for the data that you actually want to store. And there's various tools you could use for this. Again, we have a really nifty tool called the Schema Builder. On your left, you could see an image of it, and if you want to scan the QR code, you could. And that's like a good YCWG. What you see is what you get type interface that essentially allows you to generate a schema. If not, you could also write your own schemas, and we have extensive documentation on our website where you would learn how to generate your schemas. So once you have your schema, again, just to review, so now we finished all of the setup applications for you to do it once. So then I don't think, one, because I don't work for Lens, I'm not going to show you how to query Lens. But essentially, it's a very simple process. It's a simple graph or QL call that you're making from your application to Lens, and it becomes a really simple process. And from there, so let's say that you've actually gone. So as you saw in the demo application, I connected to Lens, and I pulled certain bits of information. I pulled my name. Well, I pulled the user's name, the number of followers, the number of people who are following them, and their ID, essentially. And from there, I could make a request back to the Polygon ID issuer node and make an API request and say, I would like to get a verifiable credentials for this particular shape of data. And the data that you see at the top there is like the schema that we defined, and then you have the credential subject that is the ID is the ID of the user that has scanned the application and has given us his decentralized ID. And we have the number of followers and the lens ID, and all of these we are committing into the verifiable credentials. But specifically, I'd like to call your attention to the request method. If you see slash, it's v1/issuer_did, and the issuer did that we created in the third step is what we're now writing. Is what we are now issuing claims against, right? So that's why it's important. And when it's actually created, what we get is a claim ID, and you see that in the response. And lastly, once you we essentially have a convenience function that allows you to be able to convert that data into a QR code that is acceptable by the Polygon ID wallet. And the API request path takes the issuer did that you created in the second step. The second step. And then the claim ID that you just got, and you could scan this, and you make the request for it to be formatted in a way that would be accepted as a QR code, and you embed this information. And with this information, you could use any QR service, and I use qr.io and make an API request, and it generates a verifiable credential. A QR code that I could open up the Polygon wallet and scan. And lastly, again, I'm just going to take you through the demo, so you could see, hopefully the concepts now are clearer in terms of what's happening on the back end. We're signing. This is how we query the Lens API. We get the Lens API, we get all the information. We create the Polygon ID issuer. Once we have the issuer did, we get the user's credential, and this step could be replaced with a scan of from the Polygon ID wallet, and create a QR code, and that could then be held in the user's wallet. So that is essentially how we could build that step of the interaction. So what do you do with it, right? So once the verifiable credential is held in the user's wallet, how does it matter? Because I knew I wasn't going to have enough time to go through the full demo of what to do with the verification piece, Steph had actually built a verifiable credential gated dApp that you could actually go and review, and you could actually build now the other side of it, which is the verification piece, and you could prove the particular application of her dApp was that you had to prove you were born before 2023 to actually view it. And there's a whole process involved with the whole verification space that I will not get into just in the interest of time. And yeah, here's the link to the VC gated dApp that you could look at. That is now the catch. So I'm hoping that this demonstrates like how to do the pitch. The pitch is like, how do you get information? How do you feed it into Polygon ID? And then the other piece of this shows you, okay, now that you have the information, how do you token gate, how do you VC gate your dApp so that it could actually consume the verifiable credentials held by a user on their phone? Yeah, that's essentially it for me. Thank you for listening. This was 25 minutes.
Thanks. Question about verifiable credentials in general. So let's assume that I have a bachelor degree and now I want to apply at Polygon Labs. And how do you know that the issuer is really my university of that credential?
Yeah, that's a really good question. In terms of I guess the actual roadmap of the evolution of the Polygon ID product, that would essentially mean that we have your university signed up as a issuer that is issuing credentials about you, and your university will have a decentralized ID, and that decentralized ID would essentially uniquely identify your university on the Polygon ID system and on the specific chain that they were implemented on.
So there will be like a on-chain registry mapping the university to a DID.
Yeah, essentially you have the DID held. Once it's then issued, it doesn't have to be on-chain. That is entirely up to how we want to do it, but we have like allowed issuers and the whole verification process. But once we have your university's decentralized ID, we could use that to verify the authenticity of the claim that was issued. So on the verification side, we would know what that would look like. Yeah.
But each verifier has to know this mapping, right?
Not necessarily. Yeah, you want to answer?
Sorry, maybe I can answer a bit about this. So the issuers will publish their DID on chain. That is different. So the users or verifiers don't need to publish the DID on chain. The issuers will. And they will make sure that their DID is publicly available to everyone so they can compare it with the ones that is on chain. So that is the first part of the equation. The second part of the equation is if you don't want to keep track of all the trusted verifiers, let's say to give you a proof of that you are over 18, maybe there are 100 issuers that can do that, and verifiers don't want to keep track of how many issuers are to be trusted, then you have the concept of a trust registry, which is something that in the world of decentralized identities quite well known, right? And it's basically a governed, it can be with decentralized governance or whatever, but it's a registry of issuers that have passed certain qualifications criteria, and then as a verifier, you will say, I will trust any credentials coming from any issuer that is part of the trust registry. So the first part, the DID on the chain, is already implemented. The second part, the trust registry, is on the roadmap. Thank you.
Hello. Yeah, actually, my question was on that. So I guess which trust registries are you guys adhering to? And my other question as well is, which DID methods are you using? And does the user have to, like, does an issuer need to install the node, the Polygon node, to issue a credential, or can they do it themselves as long as they're following the same DID method?
You want to take it? About the trust registries question.
Sorry again. Sorry, Tony, to take over.
No, it's fine, it's fine.
There are three methods to issue credentials. You can install your node, which is the most decentralized way, and we did it that way to keep decentralization to the maximum. But then for the sake of adoption, we are partnering with companies like Doc, which are providing this as a service, like a SaaS model. So that's your choice, right? And then last but not least, we have a GS SDK that also have issuing capabilities. You could even issue credentials from an application or from a mobile wallet or from anywhere where you can run JavaScript code.
Hey, and part of my question might have been briefly adhered to by the last answer, but obviously VCs and DIDs have been around for longer than zero-knowledge proofs. How do you think zero-knowledge proofs can, if they can, supplement the verifiable credential ecosystem, especially now that they're coming to Polygon as well?
I mean, you have the product manager here, so I'm going to defer to him.
Sorry, I didn't get the full question. Can you repeat it, please?
So how can zero-knowledge proofs supplement what
Oh,
verifiable?
how long do you have? There is a paper, actually, I would refer you to. There is a paper that we wrote about how we use zero knowledge in different layers of Polygon ID. So the answer, let's see. So first of all, for example, some examples, right? The coupling, decoupling your keys from your DID, right? That's very important. But then you need a cryptographic proof to link one to the other. But I think one of the most interesting cases is, I mean, the obvious case is to share proofs instead of sharing information. That is the thing that comes to everybody's mind. So instead of saying that this is my country of residence, I just need to prove you that my country of residence is not North Korea, right? That is the most obvious use case. But beyond that, you can use that for data compression. You can use that. Then a more esoteric use case would be we have now something called the on-chain issuer, which I find it amazing, honestly, because what you are using the blockchain to make an attestation about a procedure, right? So you have, let's say in your phone, you have a process to scan some NFC card, some passport or whatever, right? And then you have specific circuits that process that information and provide a zero knowledge proof on chain, right? That says I have followed a certain procedure, right? So basically, you're using the chain as a source of trust to make an attestation about you being a reliable issuer. So you're doing self-attestation. There is no third party involved. You're creating a credential for yourself, and the chain is the witness that will certify you. And all that is possible just because of zero knowledge. Well, no, it just makes the identity holder and the issuer the same process, but in two different parts of the process.
And I think that's our time. Yeah. Thank you very much.
Thank you.